All right, guys, here we go. So today, 5/18/22. Today is actually Mount St. Helens Day. Yeah. May 18th, 1980. I was there.
St. Helens?
Yeah, it is blurry. I don't know why it's so blurry. Well, shoot. Well, we'll do our best, because once it starts to record, it won't change.
Mr. Davies. It's also tangent.
I know, okay, there. Yeah. I want to keep teaching. No more distractions. We're going to teach, okay? So our objective today, here's our objective, is we're going to set up and solve similar triangles from parallel lines and bisectors. Okay, sorry it's blurry. Once it starts to record, the machine won't readjust, okay? Okay. So we just saw this. We saw this in our journal, and they want to say TR goes to QT as RU goes to US. All right, that works. For me, it's easier if I just use A's, B's, and C's and D's, right? If I call this length A, and this length B, this length C, and this length D. Another way to look at this is you could just set it up as A goes to B as C goes to D. And yeah, there are other ways to solve it, but this is just the most basic way. This piece goes to this piece as this piece goes to this piece. But the lines must be parallel. Parallel. Golly, I can't spell, can I? There we go. So if that's the case, let's look at example 1. Example 1 is pretty easy. I definitely see parallel lines, right? And because I see parallel lines, let's find QR, all right? So I'll set it up and I'll go, okay, QR goes to 3 as 6 goes to 4. You can call QR A if you want to, that's fine also. I just use QR. So this piece goes to this piece as this piece goes to this piece, okay, that's pretty easy. So then I'm going to multiply to solve, multiply by 3, both sides by 3, multiply by 3. I'll have QR is equal to 18 divided by 4, 9 halves, 4.9 halves, 4 and a half. QR is equal to 4.5, okay? What do you think? Pretty easy? Give me a thumbs up. Okay, not bad. This is so much easier than doing parabolas and factoring and all that stuff, right? Okay, 3-line theorem, we saw that in our journal. If all 3 lines are parallel, which they are, then we can say that AB goes to BC as DE goes to EF. And if you want to put the A's, B's, and C's in there, it helps, okay? So this is like a length of A, a length of B, a length of C, and a length of D. Same thing, it's just would be A goes to B, the length of A goes to the length of B as the length of C goes to the length of D. And of course, we would solve this by cross multiplying, okay? Pretty easy. Lines just have to be parallel, and if the lines are parallel, then you got it, okay? Lines must be parallel, okay? If they're not parallel, it will not work. Okay? So if I look at example 2, yeah, the lines are parallel, right? Because the lines are parallel, this should work. Well, I don't know. I mean, I don't know about you guys, but I think it's twice as big. I could set it up, but wouldn't you think that's got to be 240? See, 150, 300? And I'll set it up also so that you guys can see it, but I could say HG goes to 120 as 300 goes to 150, right? I may as well make that 2, so let me write that as HG over 120 equals 2. I mean, that does reduce to the number 2, right? 300 and 150? The one up where?
No, under.
2? HG over 120?
No, that.
Yeah, I'm sorry, it's blurry. I don't know why it's blurry. That's HG. So then I multiply both sides by 120, Reese. Multiply by 120. And I get the value of HG to be 240. Okay. Wow, bummer, it's all blurry. Oh well.
I already have that.
Yeah, me too. I wouldn't see it at all if I took off my glasses. Okay. I wouldn't see if it was sharp and crisp if I had my glasses off too. Okay, turn the page. Oh, not yet. Okay, Ray, and I'll wait for you. Okay. Ray, give me thumbs up when you're ready. You're ready? Okay, turn the page. Okay, now, draw the angle bisector. Well, we do not have enough compasses to do this, but I want you to just watch me do it, okay? And you can come on, but unfortunately, kids, Julian, kids, I'm not saying anything, but kids break my stuff. It's so irritating. But I will do it. Here's how you do an angle bisector. Watch. Here's an angle bisector. Okay, see what I just did? Here's an angle bisector. And you can try and imitate it if you want to. I do not have enough compasses because they're all broken. So I did that, and then what I create when I do an angle bisector is 2 points. Let's make that point A and that point B. Then if I take my compass on A and make a little scratch in the middle, so I did a little scratch in the middle, and if I take and do it again on this side, make a little scratch in the middle, okay, then I get a point out here, right? Let's call that C. When I connect from the vertex to point C, it goes right through the angle. Okay, that's an angle bisector. Okay, so I created an angle bisector. So this ray cut the angle in half. So I know this angle is equal to that angle, whatever it is. 30 degrees, 30, 25, 25, okay? Now what I want to do is create a triangle. So I'm going to draw a triangle. The next piece I'm going to do is I'm going to draw a triangle. And the triangle I'll draw is right here. Now I definitely see that these two sides are not equal. They're not equal. That is not equal to that, and that is not equal to that, right? But I do know, if I use my little a, b, c's, it turns out that it's proportional. A, b, c, and d, those lengths, turns out to be proportional. I can say a goes to b as c goes to d. We learned that in our journal. A goes to b as c goes to d. So a goes to b as C goes to D. Now the book likes to do it differently, but it's the same exact formula. The book likes to say, oh no, 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 A goes to C as B goes to D. Same exact formula, it's just written in a different proportional way, okay? So if we know that, then we should be able to go to example 3 and do example 3, okay? So let's find TU, okay? So to find TU, I'm going to say TU goes to 14. TU goes to 14 as 48 goes to 24.
Wait, Tito.
TU, right there. It looks like a W, doesn't it? Sloppy penmanship, huh? Was that, I think it's Alice. Alice, is that better? Oh, that's a big blob. That's a big blob of whiteout. Okay, so I'm not done. So TU goes to 14 as 48 goes to 24. Well, it looks like it's twice as big, doesn't it? So if you see the twice as big, I say, well, come on, Mr. Davies, you don't have to do the math. I know that's 28. You guys okay with that? Twice as big? Or if you want to do the math, you could. You could TU over 14 equals 2, right? Because I just reduced that times by 14 times by 14, and I get 28. What do you think? Pretty easy day? I think so too. Let's see if I can stop this recording. Come on, stop. Come on, stop.